As Alex mentioned, we are losing biodiversity at a faster rate each year. So in the left, you can see a graph where you see the number of species losses through time. And you can see for amphibians, mammals, birds, reptiles, and fishes that we are losing species at a faster rate. And this is something very important, and bees are not an exception to this pattern. We don't have so good data for bees, but all the evidence say that all over the world, bee diversity is also declining and following a similar pattern. And because I am going to talk about land use and habitat for bees, it is important to talk about pesticides, and it's important to talk about agriculture and in general what we call external inputs. So external inputs is everything that you put into the farm to make seeds or fruits, and it is consumed during the production process, like pesticides, fertilizers, etc. So you can see there that the global consumption of pesticides is also increasing through time. So on the one hand, we have a global loss of biodiversity, and on the other hand, we have a global increase of external inputs almost everywhere. So, which is the main cause of biodiversity loss is what we call land use change, which is simply transforming these natural and semi-natural diverse habitats into monocultures. Here we have a soybean monoculture, but it is the same production process for the trees. We have also an industrial process for trees, and also for industrial crops like oil palm, wheat. Even in our gardens, in many places in the world, we expend a lot of water and land to cultivate grass monocultures that they are not any good to the environment. So this is not only a problem of biodiversity lovers, and it's not only a problem of the bees, as it's also a problem for human beings. Um, IPBES is an intergovernmental platform where we can discuss more later about IPBES, and we have classified nature contributions to people into 18 contributions, and we have seen that in parallel with this decline of biodiversity, 14 of these 18 nature contributions also declined during the past decades. The other four, they do not increase, but we found contrasting trends according to different indicators and different trends in different regions. And these nature contributions are important as, for example, providing clean water, regulating climate, and of course, pollination, biological pest control, food production, etc. So according to this, we have been doing a poor progress into HE biodiversity targets and the sustainable development goals that we can also discuss more in detail later about this. But these are general agreements that we put as a global society and that we did not achieve at all. Um, so our planet and is looking like this house. So previously, our planet was able to provide a good quality of life, and nowadays the uh, pillars of nature contributions to people, which is biodiversity, the diversity of species that provide these contributions to good quality of life, are declining, and then we are suffering the consequences, and the planet is losing its capacity to sustain human life, at least from the natural ecosystem services. Um, so we have seen that the main cause of biodiversity loss is land use change, and is the way that we are performing land use change that is based on a process that is called conventional intensification. And this process as I showed you before, it's based also on large-scale monocultures and a great use of external inputs. And this is because it's a way, it is a simple way to increase crop yield. Crop yield is productivity per area. This is the amount of seeds or fruits that we harvest, for example, per hectare. So land use change is the problem, agriculture in general is the problem, but it's also the solution. So instead of performing an agricultural practices that are destroying biodiversity in general and bee diversity in particular, we can perform agricultural practices that promote diversity and which is based on diversity and ecosystem services that diversity provide to crops. And this process is called ecological intensification. So the idea is that provide resources to the crops using less external inputs, for example, using less fertilizers, and instead promoting soil health and the diversity of the animals in the soil that provide nutrients to the plant. So in this way, we enhance diversity to replace, complement, or create synergies with these external inputs. And this is a process. So we work with the farmers and agricultural enterprises, the growers in this process. And each year, what we are doing is to increase diversity a little every year and to reduce external inputs a little every year. And of course, in this talk, we are going to focus on the diversity of pollinators as an example of a process of ecological intensification that can create a healthy environment for the bees and at the same time increase crop productivity and using sometimes less external inputs or optimal external inputs. In this case, we are going to talk about, for example, managed pollinators and, for example, hives of honeybees that you bring from outside the farm just for the pollination process and then you take out to another farm. This is also an external input because it's not generated within the farm, it comes from outside and then you move it to another place. So ecological intensification is a nice concept, and of course, everybody agrees with the ecological intensification. So one question is why not everybody is using ecological intensification? Um, Sorry, can you listen to me? Just to check my connection.
Yes, it
Great.
the audio is good. It's good. Yeah.
Yeah.
Thanks for checking.
So ecological intensification is it's a great process and it's a great concept. So then why not every grower use ecological intensification? So we might think that not everybody use ecological intensification because you obtain less crop yield. So farmers obtain less productivity, so they don't want to perform ecological intensification and they opt for conventional intensification. And we have asked this question through an experimental setup during 5 years in 33 crop systems all over the world. So in each one of the blue points there, we did similar experiments to what Alex showed for almonds in California. We have, for example, the blue point in South Africa was many sunflower fields. So half of the sunflower fields were managed with the conventional intensification practices, and the other half of the sunflower fields were managed in a way that improve pollinator diversity and abundance. And we have found that in general, these practices of ecological intensification that improve pollinator diversity and abundance also improve crop yield by an average of 24%. Of course, in some crops is more, in other crops is less, but overall 24% is a lot. and there was a high consistency all over the world that there was an important pollinator deficit, and that could be uh, quite relevant for increasing crop yield. So it is opposite to the idea that ecological intensification provide less yield. Ecological intensification provide more yield. So then we might think that the growers don't use ecological intensification because it provides less money, it is less profitable. And there is less information in this regard, but we have reviewed also the evidence of different studies doing the profit analysis of the different approach, and we have found the opposite, that per hectare ecological intensification in general gives more profits to the farmer. So, and this is logical because on the one hand, if you have more income because you increase productivity, and on the other side you have less cost because you need to buy less external inputs, then you have more profit. So then why not all the farmers do ecological intensification? And we are working on this a lot, and there are many barriers to ecological intensification, but one of the barriers is that you need ecological knowledge. So conventional intensification is very simple. So you have your seed, you have your agrochemicals, and everybody plant soybeans in the same way using a very simplified landscape, irrespective even sometimes of local aspects of the soil or the climate. So conventional intensification, we say, conventional intensification is less intensive in the use of ecological knowledge, but is more intensive in the use of external input. In contrast, ecological intensification needs less external inputs, but you need to apply more ecological knowledge. So Alex was mentioning about different practices for ecological intensification, like flower strips, etc. So you need to know, okay, which seeds are you going to plant, what is going to be the effects on the pollinator community, how these effects is going to translate into crop yield, is going to increase crop yield, how much, where are you going to restore native or or natural or semi-natural areas, etc. So knowledge is a barrier for the inclusion of ecological intensification into farming nowadays. And we are working a lot with the growers and farmers in Argentina, but also all over the world, in trying to reduce this barrier and co-develop this kind of knowledge, practical knowledge, in-field knowledge with them. So the idea is that pollen is also a resource, as Alex explained, that the plants need to produce seeds or fruits. So you can think about water as a resource that enters through the roots. The same is for the nutrients. The light is another resource that enters in the plant through the leaves. And pollen is a resource that enters in the plant through the flowers. So if you have less quantity and quality of pollen, you're going to harvest less. And again, this is an example of a resource that can be provided as an external input, for example, through hives of honeybees, or as through biodiversity, through wild pollinators that grow spontaneously in the local landscapes. So, summarizing many studies all over the world, including those that Alex described, we can take a look at this graph. So this graph again has how crop yield vary as a function of, in this case, instead of pollen, we have flower visitation rate, that is the amount of visits the flower receives, the amount of visits by pollinators. And instead of one curve, we can see that we have two lines. The upper line is referred to high richness of pollinator species, so high bee diversity, for example, and the line in the In the bottom, it's one that it says low richness of pollinators. So that can be the scenario of only one pollinator, only honeybees, as Alex mentioned. So if you focus first on the line on the bottom and you move from left to right, you can see that when you put more hives of the honeybee, crop yield increase until the optimum. And then if you put too many hives of the honeybees, crop yield is suboptimal. In contrast, for the same amount of bees, if you have more diversity, the crop yield is greater. So if you move from the bottom to the top part of the graph, you increase diversity, and if you move from left to right in the graph, you increase abundance. So this graph is very clear, and it's also described the scenario that Alex mentioned, that you need somehow both. You need abundance of bees, and you also need bee diversity. So uh, our agricultural landscapes nowadays looks like the photo on the top right of the screen. That is an almond monoculture, and also a honeybee. Um, it's not a monoculture, but a single species management. So our approach to agriculture is to destroy diversity and to focus only on one species of plant and only of one species of bees when bees are managed. And of course, honeybees are great and we love honeybees, but we are asking too much for one species. And one species can never replace the role of many, many species, thousands of bee species that are historical uh, evolution in many places in the world, and they have a critical role for crop production, but also for the environment. So this idea that external inputs can replace biodiversity is not correct. And it has this sense that abundance can replace biodiversity. And we have seen also in many ecological studies in agronomy, but also ecological studies in general, that abundance can never replace the role of biodiversity. So we need both, and this is an idea that is very inside us, as you can see in the photo of the top right of the screen, that we create this landscape that are based on landscape without any diversity. These pollinators are an example also of other ecosystem services that cannot be replaced by external inputs. For example, we cannot destroy the soils and just put fertilizers. And this is an important concept that goes beyond pollination and pollinators. So here we have the same. On the left graph, we have fruit set, and on the right graph, we have seed set. And we can see how fruit set and seed set increase with the increased amount of honeybees until an optimum, and then too many honeybees is not so good for the crops. We try to think that when we manage pollination with honeybees, putting more honeybees is always better, but this is not the case. Many studies are finding that there is an optimal abundance of honeybees for crop pollination. And this is adding too many honeybees is not good for crop productivity, and it's not good for the environment. So honeybees in many places in the world are non-native, and here you can see a beekeeper that is moving honeybees for crop pollination in California for almond. So suddenly to these landscapes, we bring in millions and millions and millions of honeybees that putting too many honeybees, they compete with the native bees, and they have a detrimental effect also into the environment. So are we going okay? Can you listen me correctly? Hello?
Yes, we can hear you.
Ah, thanks. Great. So, uh,
Oh,
from a very narrow point of view, that is crop yield, we need both to manage species. So we need abundance of species in our croplands to pollinate our crops. But we also need habitat. We also need natural and semi-natural habitat within working landscapes, within our agricultural landscape. We need both. The habitats provides the diversity and abundance of wild beasts, and of course, species management is also critical for crop pollination. However, conventional intensification does the opposite. So, for example, you can see this is a very important agricultural enterprises that has planted new orchard crops, and they are trying to plant as far away as possible from the rainforest. They don't see any value of having the rainforest close to their orchard crop. And as Alex also mentioned, having your orchard crop close to a natural or semi-natural habitat is really good because you have more diversity of bees and you have more crop productivity, not only in quantity of harvest, but also in quality of harvest, which is an important aspect that Alex mentioned. So these conventional intensification practices reduce natural habitats within agricultural landscapes. Then you decrease the diversity of bees in particular and pollinators in general. You have less pollination. Then you have a lower crop yield, as it could be. So then you have more agricultural area because consumers demand amount of production. So if you produce less per area, you need more area to produce the same amount of, uh, of product. So this expansion of agricultural area that happens mostly in the New World and the tropical and subtropical areas um, is reducing again natural habitat area. So you have here a negative cycle in terms that you have less natural area,
I'm
less
not sure whether we
diversity of
can hear you
pollinators.
right now, Lucas.
Sorry, can you hear me?
Here we go. Yeah. Yeah,
Okay,
now it's good.
great. So you have a negative cycle in which you have less natural habitats, less diversity of pollinators, less pollination, reduced crop yield, and then you need to compensate again with more agricultural area. So this negative cycle is based on the huge pollinator deficit that we have found that I showed you at the beginning of my talk, that 24% of potential increase in crop yield. And why is that we are finding so uh, clear pattern that all over the world in general, crops needs more pollen, and this is because pollinator deficit is the result of demand and offer of pollen. So on the one side, we create these large-scale monocultures that demand a lot of pollen. So we have a huge demand, but at the same time, we destroy the environment for bees. So the offer of pollen is very little. So as a result, we are creating a huge pollinator deficit with our conventional intensification practices. So conventional intensification practices is the perfect recipe for pollinator deficit. So far we have seen the benefits of creating these agricultural landscapes with natural areas and semi-natural areas that provide diversity of bees through a narrow perspective only through increasing crop yield. Now we are going to discuss a little bit another benefit of natural areas. I have told you before that we have classified the contributions of nature to people into 18 contributions. Uh, we discussed only one, which was pollination. Here I'm going to discuss a second one, which is about the regulation of water cycle. I'm not going to discuss the 18, just I'm going to give an example with water. So we can see also the importance of natural areas, not only for pollinators, but also for other services that humans need for good quality of life, and how we can create synergies in which we perform practices within the landscape that improve biodiversity, but also improve other services that are important for good quality of life. So here on the bottom left, we see Cordoba province, which is probably almost the size of Spain in Argentina. And the yellow points are points where we measure the water in the soil. And we measure how close is the water to the soil surface. And on the top, you can see what is the trend through the years of the water in the soil as an average of all those points. And you can see that there is a line that is going up, uh, and that means that through time, the water is getting closer to the soil. That means that we have a lot of new flood areas that they weren't there before. So new floodings everywhere in thousands and millions of hectares all over Latin America and in many places in the world. So on the bottom right, those black circles are new flooding areas that they weren't there before. These are new water reservoirs that there were areas that before it could be cropped. So here on the top, you can see the cultivated area, and on the bottom, you can see the crop yield of the two main crops of Argentina, that is maize and soybean. And these are very important crops all over the world. And you can see that during the 80s, this is an example of um, kind of a department within the Cordoba province, but it's an example that is commonly repeated all over Argentina and in many places in the world. And you can see in the graph on the top that during the 80s, 50% of the area was cultivated. Then during the 90s, there was an expansion of the conventional intensification process, and we wanted to cultivate everything everywhere. And we reached until the 80% of cultivated area in 2010. And then we started to have a lot of problems because of flooding and excess of water. Then we have to abandon a lot of areas with crops because we couldn't cultivate anymore because of new floodings everywhere. So nowadays we cultivate 60% of the area. So 20% of the land was claimed somehow by nature. And these are degraded lands that do not provide any services anymore. And the reason because the floodings started to happen is very simple. So before, the soil was covered the whole year with natural or semi-natural vegetation, and these plants were transpirating during the whole year. They were taking water from the soil into the atmosphere. Then we converted everything to agriculture, and we planted crops that they were present only a few months per year. And these crops transpirated less water than the natural and semi-natural uh, areas. So then, as you have seen in the previous graph, water started to accumulate year after year, year after year. And now we have new rivers. We have a lot of problems in many places because of this. And on the bottom, you can see that during the 90s, that when conventional intensification expanded, crop yield actually increased. But then crop yield did not increase anymore. So we are seeing that conventional intensification is creating a lot of environmental problems, not only for the bees, not only for society in general, but conventional intensification nowadays is creating a lot of problems for the same growers, for the growers itself. So nowadays, many growers are really interested in listen to what we have to say, and they are more interested than 10 years ago or 20 years ago in how to apply these ecological intensification practices that promote diversity into the farms and bee diversity in particular. So
Lucas, I
yeah,
apologize. Just a quick time check. We have about 5 more minutes.
okay,
Thank you.
okay. So so far as a global society, we have agreed that through the Aichi biodiversity targets, we have agreed that we need natural reserve in each country, and we have agreed to 70% of the country area of natural reserves. But there is no global agreement about the need of natural areas within working landscapes. There is no Aichi biodiversity target in this regard, and this should be included also in the international agreements. And this is very important for the bees, for the beekeepers, and also for the diversity of wild bees. So it is important to include also natural and semi-natural areas within the working landscape that cover most of the global area, and most of these working landscape are with agriculture, ranching, or forestry. And in this regard, we have been working a lot with mathematical models based on real data, taking into account the cost of maintaining natural and semi-natural areas into agricultural lands, and also the benefits. And of course, there is no magical number, but we have seen that we need to restore in many of these places natural and semi-natural areas at least to a 20%, and this do not imply a cost to the growers. So at least a minimum of natural and semi-natural areas of 20% does not imply an economic cost to the grower, and does not imply a reduction in agricultural productivity. Of course, there is a lot of regional variability. In some places, it could be up to 50% of natural habitat. We have mapped all over the world which are the places that have less than 20% of natural habitat. And these places are those with more red, as you see in the global map. For example, in many places of Argentina, United States, Europe, India, China, etc., the main agricultural places in the world. And of course, with the percentage, it's not enough. We also work with models, understanding the quality of these natural and semi-natural habitats, how to design these restoration practices into fields, and the time that it takes to deliver benefits. And we work with the algorithms and satellite images in moving from the, if you see in the second row, of those maps. They are all browns because they don't have natural areas, and we help the growers to design how to move from the second row, that is everything is brown, to the third row that you have at least 20% of green, that is natural and semi-natural habitats, how to design them into the landscape, where to restore, what are going to be the cost and the benefits, etc. Here's an example of a big agricultural farm in Argentina, where we are doing this with biological corridors. And then also, because there were no international agreements about the importance of natural and semi-natural areas within agricultural landscapes, we checked the national laws in each of the countries, in most of the countries of the world. And we have seen a lot of variability across the countries to what they say regarding the importance of natural and semi-natural habitats in the agricultural landscape. For example, in some places like Europe, this is already established, that you need to restore and you need to have a percentage of natural and semi-natural habitats in agricultural landscapes. But in most countries, it's not like that. And the only one country that is above the 20% minimum is Brazil, at least from the legislation. All the other countries that have incorporated this legislation, they are well below this 20%. So the idea to finish is, I will give a fast summary, is to move from a negative cycle of ecological intensification into a positive cycle of ecological intensification. And we can perform practices within the crop, at the crop edge, into the border, and at the landscape, which I focus into this talk, the importance of natural and semi-natural areas in the landscape. Within the crop, there are many practices that we can perform. Here was an example by using less herbicides. You have more crop yield because you improve flowers and pollinators, and uh, herbicide-resistant weeds are a huge problem everywhere, and these kind of ecological practices are important because herbicide-resistant weeds are one of the main problems of conventional intensification nowadays. Many of these weeds have flowers, so managing this weed through ecological intensification practices is the perfect way to increase pollinator, reduce herbicide, and promote healthy environment. This is another example in an area that covers more than 30 million hectares of crops. We measure more than 4,000 fields, and we have found also that crop areas that are closer to natural areas, that they have more landscape diversity, they have less weeds that are resistant to herbicides, the importance of restoring hedge in the rows, even for soybean. Uh, and here, the last part was about multiple benefits of this restoration, not only through bees, but other nature contributions to people, like biological pest control, soil nutrient cycle, and also improving the stability of crop yield, and also in providing jobs. We have found, this is the last example, that landscapes that are more diverse, they are also providing more jobs opportunity, and unemployment is an important problem in many places in the world. And they also provide more friendly environments for beekeepers, so they have positive externalities instead of destroying the environments for beekeepers. And then this is also to relate more benefits of environments that um, provide pollinator health and how it's related to human health. And we have found four pathways. One is through nutrition, the pollination of food crops, but also providing food itself. The other one is through medicine. There are more than 28,000 medicinal plants all over the world that depend on pollinators. The other one is through mental health, through the promotion of green spaces, and biocultural landscapes, and also pollinator uh, center initiatives that reduce pesticides and pollutants. They create better environmental quality for humans' health. So, in summary, bee friendly are human friendly environments, and this is our 10 practices to perform for ecological intensification at the different levels. And this is a conclusion that we wrote with Alex, that in general, to maintain pollinators and their critical services, we need a holistic approach, and we need to engage the whole society, as we are close to tipping points when species get lost and ecosystem functions services collapse. Thank you. I think I was more or less okay with time, but with the
Yeah.
connection problems, we delayed a little
Yeah.
bit.
Thank you so much. I wish we would have a little bit more time because
Yeah,
there was so much
yeah,
at the end when you were speeding up. And this,
yeah,
what a beautiful conclusion.
yeah.
Thank you so much, Lucas Garibaldi.
Thank you.
Um, we have only about 5 minutes left till the end of our conference. And why don't we just jump into the questions into the chat? And Francis was very prolific in sharing some questions with us. Um, why don't I start reading the first one? So Francis says, monitoring the visits of honeybees in a region, could you optimize the density of hives, optimal abundance in Switzerland, extreme densities competing the wild bees and spreading pathogens?
Yes. So we have also a protocol to do that because, for example, for a farmer, if he's going to apply a fertilizer, he's going to first to monitor the soil. If he's going to apply a pesticide, he's going to first to monitor the pest. But for pollinator management, there is no monitoring. So usually the farmers and the beekeepers, they do not monitor the flowers. So you need to do flower monitoring, and according to flower monitoring, design optimal numbers of honeybees that they are grouped for the crop, and they are also good and optimal for the environment.
Thank you. Another question from Sonia. She says, as gardeners, we are not interested in honey, but in vegetables, with our main goal to recreate a natural balance in our garden. Listening to you both, I'm wondering if the focus should be entirely on attracting wild solitary bees and other pollinators and not to worry about the honeybees, as very likely also in our area the intensity of honeybees is already high enough, and hence would it be better for the natural balance to have more other pollinators, correct? Any thoughts?
I think that I generally agree with that point. I can emphasize that
Is
in
Lucas
general.
frozen right now? Oh no, here we go.
Okay. Can you listen to me? Yeah. Hello?
I understand you, Luca.
Okay. In general, I agree with that point, and I would add that if you perform practices for enhancing solitary bees, that is going to be also good for honeybees, because honeybees also need diversity of flowers to be healthy, and they need diversity of pollen and diversity of nectar also. So in general, if you focus on the rare species, on the less frequent species, is a good strategy, and then you're not going to do damage by doing that on to the honeybees. They are going to be promoted anyway.
We actually know this, for example, from Rachel Winfrey's studies and other studies. When you have a healthy environment, a small scale farming like in a garden, you don't need the honeybees in general. But honeybees also have their role. For example, in California almond, you have this weather going up and down and up and down, and you have the rain coming in. The bees that I showed you, they are all ground nesting bees at this time of the year. And they're not coming up again when there was rain. The nests are very wet for a long time, but the honeybees are foraging there. So they have their role. And to the earlier questions for bringing honeybees and competing with wild bees, or your protocol, Lucas, I totally agree. You have to monitor how many bees are there, and then you can decide if you bring in honeybees or not. But the problem is, if you don't know what kind of weather you are getting, you might fail the wrong decision. And this is why farmers are bringing in honeybees, to make sure they have enough bees. But they might get overpollination. I mentioned this, and I think Lucas mentioned it as well. Too many honeybees can also bring a lower crop yield, or especially quality of yield. So it's kind of complicated.
Yeah. Well, I wish we had more time to continue this conversation, and there are also unanswered questions. But unfortunately, we are running out of time. We are reaching the end of our time. And I would like to say one more time, I would like to thank you both for coming and sharing your time and knowledge and enthusiasm with us. And definitely, we all probably made lots of notes to read your studies and to continue to follow your research there. But that is quite an important resource for the field we all work in. So again, big thank you to you all, and for our audience. Our next conference series will be on June 4th with David Heath and Michael Bush, and more details are already published on the website of Free the Bees. So thank you very much for coming, and I wish you all a wonderful rest of your day. Yeah.
Thank you.
Thank you very much.
Thank you. Thank you very much.
Thank you so much.
Have a nice day or evening.